is Amber Gell of the Lockheed Martin Corporation. She is spacecraft systems engineer. Amber Gell, future astronaut. As you read in your program, Amber is a remarkable woman in the aerospace field. Just to give you some of her highlights, Amber is currently part of the team designing and building the Orion spacecraft, the multi-purpose crew vehicle, NASA's new spacecraft for deep space exploration that will use to take humans to the moon, asteroids, Mars, and beyond. She's done a heck of a lot of interesting things, which she's going to tell you about in her talk. Right now, she splits her time between rocket science, numerous outreach education efforts, microgravity research, lifelong learning, and fitness activities. Amber also received the 2013 Women in Space Science Award for her outstanding contributions to the aerospace community. Ultimately, Amber plans to join the astronaut corps and continue her passion to explore and contribute to discoveries beyond Earth, lifting not only hers, but the entire human spirit. She is, in short, absolutely remarkable. Please make her feel welcome.
Thank you. Good afternoon. We still awake? All right. Well, wonderful. Congratulations, first of all, for each of you getting selected to be here. It's a big honor for you guys to have reached this level of competition. And I got to judge the aerospace panel early this morning, and all I got to say is, wow, where was stuff like this when I was your age? I don't think I could hold a candle back then to what you guys are doing today. But as I was introduced, I am a rocket scientist and spacecraft systems engineer with Lockheed Martin and NASA designing the Orion spacecraft. So do I have anyone in here who likes space? Okay, so remember, I'm also a fitness instructor. I like, team involvement. I like to see a show of hands. So who likes space? Everybody? Most of the people? Fantastic. Do I have anyone in here who thinks they can live a day without space? One brave soul back there. Do you have a cell phone? Have you used GPS? Do you play any sports? A lot of the different things we interact with every single day, whether it be from the different high-tech technologies that you guys all have at your fingertips, to some of the helmets and the pads and the materials you wear when you're playing different sports and activities, a lot of those have been spin-offs from our space program. So even though you might not think that space has had an impact on your everyday life and it's just for us rocket scientist types, you're very wrong. And there's a lot of different things that you personally can be involved with if you have an interest in space, whatever your profession, career, major decides to be. Do I have anyone in here who wants to be an engineer? Excellent. What about scientists, future scientists? Mathematicians? Computer programmers? A little bit of everything. Those are all really, really wonderful and exciting careers to pursue. And if you choose to go into any of them, there are some very fun things you could be doing and interesting assignments you could be working on. But for me, I get to work on this lovely little spacecraft known as Orion. This is kind of my dream project. When I was 5 years old, I decided I wanted to be an astronaut, and well, here I am, a big kid, still wanting to be an astronaut, and I actually have the opportunity to design a spacecraft that hopefully one day I can fly on. I mean, who doesn't want to do that? So you guys are born at a really exciting time where you could also have similar opportunities, not just designing spacecrafts that you could have a chance to fly on, but perhaps a lunar lander or a Mars transfer vehicle. So there are just the endless possibilities for your age group because you were born at the right time in history. But a little bit about the spacecraft to orient you with it. First and foremost, this is what people think of most. It's the crew module. It's that little capsule-like thing where the astronauts actually will do all their living, work, science, and research activities within there. That's their transport device. Then we have the service module. There's been a change with this recently. We're actually going to have that provided by the Europeans. So there's going to be some architecture changes. And now I'm really excited because not only do I get to work with the best and the brightest from America, I get to work with the best and the brightest from around the world to help create deep space missions. Then we have this spacecraft adapter. This is what holds us on top of the rocket. So to give you perspective, there would be a big rocket beneath this, and so we would be this little piece sitting on top of the rocket. And last but not least, we have our launch abort system. Our launch abort system is there just in case it's a really bad day on the launch pad, and goodness forbid something should go wrong, that launch abort system will pull the capsule up and off away from like an exploding rocket to ensure our astronauts' safety. Obviously here at NASA, astronaut safety is our #1 priority. I mean, you aren't really a human spaceflight program or a human spaceflight mission unless you can guarantee and ensure the safety of your humans. They are our most precious cargo, and we do everything about our design to ensure the well-being of our human astronauts. But we've had a lot of milestones on the program. Our first really big one that the public kind of got all excited about, and a lot of people might have followed, you might have even heard of, is our Pad Abort 1 flight test. This is where we tested out our launch abort system, and we actually had that launch abort system sitting on the pad. Now, we didn't want to waste a perfectly good rocket, so we didn't want to, blow up a rocket and then launch it, but we were able to simulate all the important conditions by having the launch abort system on the pad, firing those launch abort system jettison motors that went up, up, up and away, and then it came down under those big red and white parachutes. Now, people spent years preparing this, and all of this happened in, about 30 seconds. I mean, you spend a lot of work and a lot of time to create something, and it might be a very quick type result. But you have to go through all the iterative design, the thought, the conceptualization, and the planning stages. Just like you guys have each done and demonstrated with your projects, that's exactly what we do as engineers and scientists working on new spacecraft. So the stuff you're learning and experimenting with now is the same fundamental foundation that you will have and you will use to be successful in your careers and in life, which is why this is a great program that you guys are all involved with. Our next big test flight we have coming up later this year, which I'm really excited about, and the team is working around the clock for, is our Exploration Flight Test 1. For this, it's going to be launched later this year from the Kennedy Space Center in Florida, and we're going to do kind of 2 orbits around, a highly elliptical orbit, and we're going to go the farthest humans have been in over 40 years. We won't have humans on this flight, but our spacecraft is going to go a third of the way to the moon and back, so that way we can test out our heat shield and some of the other key technologies to prove that they will actually work. So far, what you have done with your designs is you've kind of went through your concept stage, done what prototyping you could do and could afford, and now you're all here because you want to be able to prove out your designs and win that big award, right? And be able to move to the next steps. That's exactly what we're doing with Orion, is we're proving these technologies that we've worked so hard to develop, that we've invested a lot of money and time in, and to prove that, hey, they're the right stuff that we'll be able to use for deep space exploration architecture. So I'm very excited and to be part of the team and part of this project, and hopefully you guys will be following us and watching when it comes time for us to have our launch later this year. But how did I get here? Well, I came actually to Lockheed Martin to work for the Orion program. I followed it from proposal stage, and I knew I wanted to be part of designing a human-rated spacecraft. I mean, this happens once in, every 30 years? And I was born at the exact right time where I could help design a spacecraft. So I came to Lockheed Martin, and I ended up working with the landing and recovery systems. When you think of landing and recovery systems, what do you think of? 3 big red and white parachutes, right? That's pretty much about it. The time you re-enter the atmosphere until, well, those come out. Oh, but wait. There's actually a lot more to it than that. It's not just getting those parachutes out and right and decelerating it at the exact appropriate rate to get it to land nice and smooth and not damage our precious human cargo. Oh, no, but wait, you're landing in the ocean. Well, what if a wave hits it wrong? What if it doesn't float? What if it flips over? What if our astronauts suddenly are in it and get really bad seasick? How long does it have to stay afloat for? And by the way, if a spacecraft is smooth and aerodynamic, how do I attach anything to it to actually be able to recover it? And does it have any hazardous propellants? Or is it too warm to the touch? Or how am I going to get this darn thing back and get my astronauts off it? All those things that never even crossed my mind until I got to actually go and participate in some of the landing and recovery working groups and sessions. And one of the things we had to figure out was, well, testing out the spacecraft to see its characteristics and its dynamics. Now, I'm not going to claim to be an oceanographer or know enough about sea states and all that type stuff. But the fun thing is you work with a team and you learn it. You have a challenge, you have a problem to solve, and you take the best and the brightest you're working with and you just face it head on and see what you can come up with and really incorporate everybody's ideas together. And not only that, you get to get hands-on with doing it. One of the things I liked personally was I got to go spend a week of my life living out on a boat. I mean, I'm an aerospace engineer. I work with spacecraft. Who would have ever thought I'd be out in a boat in the Atlantic Ocean, dropping a spacecraft into water in all different sea conditions, and then going out in a little rigid hull inflatable boat, this orange thing, also known as the Ambar, and have to recover my spacecraft and see how we could possibly attach stuff to it to do it, and work closely with the Navy divers who will actually be doing the recovery of the official spacecraft. This was a whole new experience that I'm really excited to have, and as an avid scuba diver, I always wanted to go out on this boat, the Liberty Star, because this is the boat that did NASA's solid rocket booster recovery. They weren't really flying the shuttle as much anymore and doing the recoveries, but I had wanted to go on this boat and help with one of the dive operations to get a solid rocket booster back. I haven't gotten to do that, but I did get to do something else that I thought was pretty cool. And that's really an important point to iterate with your career. What do you personally, each of you, want out of your career, want out of your life? I mean, I want to be an astronaut, but whether I get there or not, I want to have all the different analog experiences I can have, that the only difference between me and an astronaut is flying in space. Other than that, I've gotten to do everything an astronaut gets to do, along with some of the training and the analog settings, and it has just been so exciting and rewarding for me. But nowhere in my job description did I get to say I'd be doing any of this stuff. It's all about asking the right questions, paying attention to the different projects, the different things people are working on, and not being afraid to go up and ask people when you're interested and when you feel like you personally can have something to contribute to that area. After working landing and recovery systems and doing well with that, they actually asked me to lead up the docking integration efforts. I had studied orbital mechanics, and that was kind of my area of expertise when doing an aerospace degree. And this was a whole new challenge, because it wasn't just, how do you bring not only one but two spacecraft together in orbit going 17,500 miles an hour, but then you have to think about all the different other issues, the human factors involved in it, the pilotability assessments of how you actually fly this spacecraft and what it all entails. And let me tell you, I had never flown a spacecraft, so I didn't necessarily even know what I was getting myself into. But just like you train the astronauts, I first of all had to get trained in these things called docking simulators. We had one at the Lockheed lab, and then NASA has this big dome, which is just absolutely amazing. Do I have anyone in here that likes computer games? It's okay, you can admit it, me too, that's fun. So now, let's see, when you have a computer game, what do you have? You maybe have like a Wii joystick or some type of controller, right? And then a TV, maybe a really big TV if you're lucky. That's pretty much as cool as it gets, right? Now imagine this. Imagine you are in the aft shuttle cockpit, entire mock-up, full scale. Now, not only that, you have all your different screens, which are all of the shuttle windows. And then you're in this big dome that everywhere you look around you, it feels like you're in microgravity, it's moving. Granted, you still have gravity, but it gives you that essence of orbiting the Earth. And when I'm not flying the thing, I could just stand there and watch and imagine I'm on a spacewalk, because it's so realistic. And yes, that is how we train our astronauts. Now imagine getting paid to do that. Would anyone like to do that as their job? Yeah, I mean, and so to do a docking, what do you think docking entails? It's the moment the two spacecraft touch, right? Wrong. Docking actually involves a series of, first of all, targeting maneuvers to locate the spacecraft, and then actually get them in the same appropriate orbit, and how to bring them together at the exact right speed, which is under 1/10 of a foot per second. So it's a very slow and precise operation. It's like the most extreme form of ultimate flying. And meanwhile, you're, having to pay attention to all of this, having to understand when to push the thrusters, having to understand how each thrust impulse affects the orbital dynamics of your spacecraft, and then just getting to, be there and be part of it and witness it all and be like, this is so cool and this is my job. It's such a rewarding feeling, and that whole process takes about 6 hours. And then it would actually take an hour to get everything attached, open the airlock. We don't always go through that in the sim runs, but I mean, between prepping for that and taking it down, there's a day at work. you spent a whole day in a really cool computer game. And it's not a bad gig, it's a lot of fun, and you can definitely apply it to a lot of different things. And then you also get to be the expert who teaches the astronauts how to fly your spacecraft. But not only that, spacesuits. Does anyone in here like spacesuits? Yeah, me too. The white ones are actually my favorite, but the orange one, the Aces, aren't that bad. They're pretty awesome. They're like the high altitude pressure garments that astronauts wear when they're getting ready to go fly in the shuttle. And I always thought that the only people who ever got to wear spacesuits were astronauts, right? That's what they train you to think. Well, wait a minute. I'm an engineer. Why would I have a spacesuit on? Oh, because I design spacecraft for astronauts who wear spacesuits. So lo and behold, if you're a little creative in the way you approach your career and your opportunities, suddenly I found myself at work where I get a chance to put on a spacesuit and have to go through a whole ergonomic assessment of how I actually would design the interfaces for the astronauts. They're my end user, and as the engineer, for me to really be able to do my job and to create a good design, I have to understand what it's like to live and work in a spacesuit. Oh, but let me tell you. What do you think a spacesuit's like? Has anyone in here been scuba diving before? Do we have any divers? Couple? Okay, so that's a good feeling for microgravity and other things. Has anyone ever been up north or live in a cold weather state and have to get bundled up maybe when they were kids, have their moms put on all the jackets, and suddenly it's like out of a Christmas Story and you can't put your arms down, you're like, oh geez, I feel like this Empire State Puft Marshmallow Man from Ghostbusters, oh. That's kind of what it feels like to be in a spacesuit. Your mobility's restricted. First of all, you climb into a spacesuit from the back. That's right, and you have help putting it on because it's not just the easy one-person task. So you actually have spacesuit technicians who help you put your spacesuit on, and you climb into it, and they get you all situated, and then you put that big helmet on, and so now you're in the spacesuit, and suddenly you realize, well, my arm, who can usually reach up there, well, when it's inflated and pressurized, it can only reach about this high. And I used to be able to touch this far, this button that I put right here, that was perfect within my normal reach. Well, with this spacesuit, I can no longer reach my arm as far forward. So had I not been in a spacesuit, I wouldn't have understood that what was a great design as an engineer was a horrible design from an astronaut perspective. And then helmets. Okay, so I put the helmet on. And it's great. You can turn your head left and right and wonderful, but oh wait, I can turn my head, but I can't see all the way. My field of vision has been decreased. I can only see within a certain range that is different than my normal range of vision. So some of the buttons and switches I may have thought were emergency stuffing I could put to the side, and they could just glance at quickly like we normally can. Not useful anymore. And you have to understand the differences with that, which, I'm sure none of you, at least I hadn't, ever thought of until I actually got to go put on that spacesuit and realize all the different ways I need to go back and change my design. And stuff like that's really valuable. That's why we do tests. We like them to be successful, and sometimes some of the best test results are when they aren't. You learn from winning and being correct, and you also learn from losing. The importance is, as long as you don't lose the lesson, you never lose in life. And that's kind of how it is when you're working flight tests or design or anything with that too. And also you get to do a lot of creative opportunities if you just put your mind to it and apply stuff. Now, do I have anyone in here who wants to fly in microgravity? Oh, well, now this looks a little interesting. Okay, so first of all, why would I be flying in microgravity? Am I an astronaut? No, not yet, someday. I'm an engineer. So why would an engineer be flying in microgravity? Well, one of the things that we do and is very of utmost importance to us is microgravity research. That's the whole purpose of the International Space Station. It's the coolest research station that we have in existence, and it just does amazing things. So before you can actually fly something on the International Space Station, we like to test it out and determine all the different potential problems with it. Heck, I want to break all of my hardware while it's here on Earth or in microgravity before I send it into space. Then I want everything to be smooth and it to just go like clockwork. Planning is everything, plans are nothing. And if you try to think about that, whenever you do your approach, we had a team this morning that had technological difficulties. They did a great job and came back from it. But of course, things always throw a wrench in your system, just like we find when we're especially working with space hardware. Things can always go wrong, and there's always things you don't think of. And when you guys were presenting to judges and got critiques or get your critiques back from them, you know, they're all trying to help you and think of different things that you might not have come up with yet that are very valuable points and lessons. And that's the same reason we do a lot of microgravity research and how I actually got to fly in microgravity. So, keyword, fly. What am I doing? Am I flying there? Am I floating? No. Has anyone seen Toy Story? Do you guys know who Buzz Lightyear is? Does Buzz Lightyear fly? Does Buzz Lightyear float? What does Buzz Lightyear do? Falls with style. That is exactly what's happening right there. Me being, you know, wanting to be a superhero and everything like that, I am actually falling with style. I am going, you know, what astronauts experience when they're in International Space Station. You're going 17,500 miles around the Earth, and you are in a constant state of free fall. The space station is always falling back to Earth. We keep it at exactly 100% of the speed and rate movement it needs to go at, so that way they're in a constant state of free fall. And that's why it's important to give 100% all the time, because if you give 99%, it's just not good enough. That's how we deorbit a spacecraft. 99% is only going to get you so far, and you're just going to start coming back in, slowly decelerating your orbit until you come in for landing. That's how I land a spacecraft. I slow it down. If you just keep going, giving that momentum all the time, you're going to get there, and you're going to be able to stay up, and you're going to get to do some pretty cool stuff on the side. One of the things I got to do, I've flown a few times in microgravity. I know one of the teams this morning mentioned that they were actually getting to fly through the Hutch program. So high schoolers can actually have a chance to fly their designs in microgravity. NASA has some very cool programs and likes to get you guys involved at a very young age, and I am so jealous because I would have loved to fly when I was in high school. Heck, I would have loved to fly when I was in college. I didn't know they had a college program, too. So for those of you who are going on to become an engineer or a scientist, you can actually form a team of students, maybe stay with your current team, and think of some ideas you could help NASA out with and fly in microgravity. You submit a proposal, they choose your idea, and you get to work with an engineer mentor, which is what I have been, and design and fly your research on the zero-G airplane. We call it the weightless wonder. Some people have in the past known as the vomit comet because a lot of people get sick. No, I did not get sick. I actually love microgravity, and it is the most incredible experience I've ever had in my life, and I encourage you all to try it if you get the chance, and to work hard for that chance to get it. Now, what does it feel like? How many of you have been in a car and have been going fast over a bump and had that woo feeling in your tummy? Anyone know that feeling? Yeah, it feels nothing like that. That's what I thought it was going to feel like. I mean, I thought you were going to have that woo feeling the whole time. And you get that feeling from the sudden change of acceleration, when your car goes up, down really quick. But microgravity pilots, oh, they're smooth. They take that airplane and they fly it in parabolas. And every time they go over the top, it's so subtle you don't even realize it. My favorite thing to do coming up from when you go up, you are facing 2Gs, 2 times the force of gravity. You get to the top of the parabola, and suddenly you go down, down, down really quick. And you have, you know, essentially like 0 Gs, hence the name. But when you go over the top, they shout over the top. And I love to just lay on my stomach on the airplane, laying flat, and watch as the airplane falls away from me. I mean, that's exactly what's happening. I feel like I'm floating, falling, flying, whatever you want to think of it is. But really, the airplane's going down at a more rapid rate than I am. And it just is the most surreal experience. And it's pretty darn cool to sit on the ceiling and watch some of the other researchers work for a parabola or two, must admit. But so one of the other ways I got to fly was I actually flew as a principal investigator. I came up with an idea. I submitted my research idea to NASA. They liked it so much they decided they wanted to implement it, and they let me choose a team of university students to help carry out my research. I happened to choose some of the students from University of Texas, El Paso. A lot of different students wrote into the bid. They were the right match, and we were the first to pull off exothermic welding in a reduced gravity environment. Yeah, I'm also a welder, and I really care about being able to fix spacecraft in orbit. You know, something the size of a dime could put a hole in the International Space Station and cause it to depressurize and kill our crew and ruin our laboratory. I want to be able to fix that. But not only for that application, I want to be able to make sure that when we're sending Orion and other vehicles onto Mars, I want to make sure that my crew members have the ability to repair the spacecraft on orbit just in case it's a really bad day. I mean, you know, you're always planning for the worst and then hoping you never have to use it and none of it happens. So I'm already implementing and planting the seeds in technology that way the capability will be there, we'll have the right minds working on it, and we'll see it come to fruition. So that was a really exciting project to be part of. And there's just so many ideas. I mean, if you can dream it, you can do it. And what I love about being an engineer is I get to turn dreams into reality. I mean, that's what you're going to learn in school. That's what you're facing now. You are getting the critical thinking skills, the ability to conceptualize abstract concepts, and then really make something out of them. And whatever you're dreaming, you can do it. So if you want to be part of the space program or all the different things going on now, we have a lot of areas where we could use your expertise. We could have you involved with microgravity research. If you like some of the technologies we use and you see Earth domains, applications for them, well, yes, please come and help us out with some of the spin-off technologies. We have the team that's actually, designing the Orion spacecraft and the other different infrastructures of a Mars transfer vehicle, lunar lander, those type things to help us go and continue deep space exploration. And otherwise, there's a lot of opportunities also with the commercial crew and the commercial cargo programs that you guys can be part with. And I need you all to do something for me. Look at the person on your right. Now look at the person on your left. Now look at yourself. Guess what? You might have just seen the very first person to step on Mars. That's right. You were born at the exact right time in all of human history that someone, one of you, perhaps one of the very people in this room, could be the first human being to step on Mars. I mean, what a great opportunity in front of you. So whatever it is you choose to do, wherever it is that you want to contribute to, think about this. In your lifetime, that will happen. Where will you be? Will you be that person stepping out and being the first person on Mars? Will you be in mission control, answering the call and speaking to the first human standing on another planet? Will you be one of the engineers who helped design the craft that takes them there? Will you be the scientist that ensured they had appropriate water and air and all the different systems they need to keep themselves alive? Or will you just be one of the other millions of people on Earth who chose not to be a part of it and just has to watch on TV or hear vicariously? You get to make that choice right now and think of that and be a part of something bigger than you and something that really can impact all of humanity. So with that, we're returning to our core mission. We're embracing our human spirit and continuing deep space exploration. And with that, I would like to thank you and open it up to whatever questions you may have for me. Yes, ma'am.
Yes, you said you became interested in becoming an astronaut at the age of 5. What was it that spurred that passion, that interest? What types of toys did you play with? What was it? Where did you get your spark from?
So the question was regarding the fact that I said I became interested in being an astronaut at age 5, and she was inquiring to what sparked that interest and how did I really, catch the space bug. And to be perfectly honest with you, I have absolutely no clue. I mean, I played with both, girly toys, Barbies and ponies and stuff like that, and boy toys. I liked my cars and my Legos and, stereotypes for gender-neutral toys. Forget that, I did both. And I don't know where exactly, but it was, my first day of kindergarten, and I just remember we were sitting in a big circle. You had the little squares on the floor, and you passed around a blue floppy-eared bunny, and it's the bunny got passed to you. You were supposed to stand up, state your name and what you wanted to be when you grew up. So Bunny got passed to me. I stood up, said, "Hi, I'm Amber, and I want to be an astronaut." And my whole class laughed at me. Great way to start off school, let me tell you. And not only that, I was taken aback because you don't know how to react to that. And then the teacher, trying to calm the class down, said, "Now class, Amber can be whatever she wants, however unlikely that is." So I started crying. Oh yeah, Great way to start off your career, let me tell you. Nerdy girl who wanted to be an astronaut and class crybaby. Awesome. At least one of those things stuck. I hope it's the better of the two. Still want to be an astronaut. Don't know where it came from, but probably one of my most valuable lessons in life came from my mother. My mother, doesn't necessarily have a college education. Heck, she went to beauty school, but she was a great mom. And she sat me down and told me, Amber, you can be an astronaut or whatever it is you want to be as long as you're willing to work for it. Can't doesn't mean you're not able to. Can't mean you choose not to. You made a conscious choice that you don't want to do that when you use the word can't. Other than that, the possibilities are endless. And she's reminded me of that a few times over the years, and she's just been supportive in all my crazy adventures. So I'm very fortunate to have that. And I really hope, and you guys have supportive parents, and judging from the amount of hands I saw up going for parents here last night, I think a lot of you do. So you're already stepping in the right direction for whatever your dreams are. So, any other questions? Yes, in the back there.
How do students apply to work on your satellite project?
How do students apply to work on my satellite project? So we recently had a great opportunity for students to be involved with Orion. We had our Exploration Design Challenge because we actually had a really big problem on the spacecraft and just deep space exploration in general is radiation. I mean, you get bombarded with all this radiation when you're out there and going to Mars and beyond just low Earth orbit. And what's the best way to shield a spacecraft from it? What's the best way to keep them alive? So we put this call out and actually had students submitting proposals. I think that's already in the down select mode now. But to look out for some of the NASA challenges, they always have those going on. For whatever age you're in. There's some geared at high school students, there's some geared at college students, there's a lot of the different CubeSat opportunities. I think there's a page on the NASA.gov website that can link you to a lot of them, and I'm sure if we talk and check out with some of the people here, so see me afterwards, we can probably point you in the right direction. Conrad Foundation might even have some links or connections that they can share on their page to some of the different contests. So I'd encourage you to get involved with them as well and ask. Yes, ma'am.
You mentioned that Lockheed Martin works with other countries, and I know NASA does that too. How important is it to learn another language, or was English sort of the main language of all of you?
So that's a great question. A young lady just asked, noting that I commented about Lockheed Martin and NASA working with other countries. How important is it to learn another language? First and foremost, I encourage you, if you want to study another language, please do so. It opens up a whole new world of possibilities. However, it is not a requirement. Although for the European Space Agency and the team I'm working with, they're headquartered out of Bremen in Germany. There's some of the team members are in Italy, some are in France. But do I speak necessarily French or German fluently as I wish I did? No. Well, sadly not. However, English is kind of the common language we use with all of the different documentations, with the collaborations and meeting efforts. But now, if I can hold my own in speaking enough of a German conversation with one of my counterparts, that earns me so much credibility with them. It really just breeds fosters a good partnership for working relationships, and they appreciate the fact that you're taking the time to learn their language just as they had to take the time to learn yours. English does seem to be the standard language, but I'll tell you what, if you're actually becoming an astronaut, you need to be fluent in Russian, because obviously we collaborate with the Russians on the International Space Station, and hopefully we'll work through all the political situation and be working with them in the future. We've learned a lot from each other, and it actually helps knowing both the languages. And for the astronauts working and living on board Space Station, the countries take turns about who the commander is for where they came from. And if it's a US commander, the language on station is English. If it's a Russian commander, then the language is Russian. So you have to just be flexible and be able to learn, adapt, and always take on the challenge to an open-mindedness to accept a new culture and speak new languages if given the opportunity. So, yes, sir.
So you mentioned you made a exothermic welding project in college. Do you use that project still today in your Orion project?
So a young man just asked about my exothermic welding research. I actually did that as an engineer. on my own. It had nothing to do with my work at Lockheed Martin or my standard day-to-day stuff. It was just something I was interested in. Like you guys probably do some of your projects and research outside of school hours. It was all me working on it outside of work hours, and I got to work with the university team because NASA had encouraged that partnership, and for me to kind of get them interested. NASA has actually since put out some proposals for people to continue on and expand the welding research. I just took a completely new concept and proved it is doable. Is it the end-all be-all solution? Is it going to hold up for everything? Oh no, goodness. We need a lot more microgravity flights. We need to fly it on station, test some of these things out. But now there's a division at NASA who actually has the appropriate metallurgy engineers and some of the expert welders who have that background and heritage running with it and working on it. So I just kind of planted the seed and got it going and got the right smart people in the right direction. I'd love to, still say it's mine and run with it, but I was able to kind of hand that off to the subject matter experts and come up with new things to hopefully that I can test out again in the future. So. Any other questions? Oh, yes, sir.
When's Orion going to be ready?
When is Orion going to be ready? Well, Orion's actually almost ready now. We're having a delivery later this year, and at the end of the year, we're, as I mentioned, having our exploration flight test 1. So our first full-up Orion spacecraft is going to be ready and flying this year. So I'm very excited about that. Yes, sir.
Obviously, it takes a long time. Like you said, it took a year just to test the one launch sequence. With material science changing and us learning so much more about how different materials last in different situations and heat and so forth, with it taking you so long to build something, what happens if you have an evolution of science with materials at a much lighter, much more stable, and now you're heavily invested in older technology?
So I just got a great question from the audience. A gentleman had asked about the rapid evolution of material science these days and how it's changing, and what do we do when we come up with something newer and better and we're already so far along in spacecraft design? Well, we drew our line in the sand. For our design, we have to put our line in the sand, make our decision. We met our requirements so that we were given, and we do the best with what we have available. We would like to be able to include some upgrades, obviously as potential block upgrades, design iterations, if that's something NASA wants us to do and go. A lot of the times with the amount of time it takes to invest and do some of these flight technologies, you don't necessarily always have the latest and greatest in materials, because the same time people are proving them out, we're already a couple years into our design. And for most cases, when you design a new spacecraft, at least based on history for Apollo, for the shuttle, I mean, to come up with a new spacecraft, it kind of takes 9 years from the time someone doodled it out on a napkin to the time you actually have it full up, in concept, flying astronauts. 9 years. A lot can happen in 9 years, and a lot of stuff changes, and you just do the best you can to incorporate stuff. But just like if you're doing PhD research, you got to know when to draw your line in the sand and say, this is good enough to satisfy the need to get the job done. And we'd like to do better, and we hope there will be follow-ons and more work to test out some of the cool new stuff that there is out there. So, yes, sir.
I recall reading in Time magazine, I believe, that our smartphones have more computing power than Apollo 11. So I was curious, how have spacecraft improved over the past few decades, and what do you foresee are the most important innovations and improvements for the future?
Another great question. So our smartphones actually have more capability than the Apollo 11 spacecraft, which landed astronauts on the moon. Over the past couple decades, what innovations have we seen that have really changed spacecraft and spacecraft design? First of all, their ability to take commands from Earth. Apollo sent data back. It wasn't people here on Earth commanding it. The whole autonomous capability, ATV, the automated transfer vehicle from the Europeans, the fact that it was unmanned, and you had people, like playing a computer game in a sense, using a joystick and controllers here on Earth and mission control, docking that to the International Space Station. That's again big progress. That was completely automatic. Some of the rendezvous and docking capabilities we'll have. I mean, being able to say, loiter in a Lagrange point and just kind of hold it in one of those points is going to be much more high-tech capability than we've been able to exhibit in the past. That's going to be, advances in control systems, advances in sensors, advances in potential LiDAR and some of the docking capabilities. Being able to have the communication. We have better communication than we have. We have better human interfaces than we have. Heck, our astronauts are better taken care of than they were then. I mean, back in the Apollo days, they were your hardcore test pilots. Not that they aren't now, but we make sure that they have more comfortable living space, that they have different machines to work out with and train for strength and bone density. Because when you're in space, you lose 1 to 2% of your bone density a month when you're up there on station. So some of the different shielding practices we have, even just when there's a cosmic burst or some of the flares from the sun, they'll get a call and the astronauts actually go hang out behind their what they call the water wall, which is all their water storage, so to minimize radiation exposure when they're on station. So just some of those type things that we know better now and that we're exposing our humans to less risk up there have been major advances, and they're all seemingly little small things, but they all add up into a much more better and robust design. So great question. Do I have any more questions? Okay, so I'd like to thank you all for your attention, wish you the best of luck, and glad you made it out here. Thank you.